Hey, good day, guys. Welcome again to my channel. I am Joshua the designer, and I believe it's a very good time to wish all my subscribers a happy new year. All right, so it's a new year together with you, and I hope that this year we're going to get better, as our desire is always to get better in structural design and even in every other facets of our lives. All right, so I decide that I'm going to show you the very first model that I will be working on this year. So in this video today, I want to show to you how to model a complete structure from the beginning to the final phase in Protastructure. So this is a two-story building, all right, that I will be showing to you how to model. All right, this is a complete draft. As you can see, I have my beam detail, the staircase detail already, the slab details are ready, and the column details also ready. But I want to show to you how I model this on Protastructure. So I'll be taking you from the very beginning and to the end. Okay, so the very first thing I would like to do is to take this general arrangement drawings off this page so that I can show you on the very first page. Okay, and another reason is that I'll be using that new page to import this general arrangement into Protastructure. Okay, so but before we go ahead, let us just familiarize with this general arrangement drawing. This was produced from the architectural drawing. Okay, so looking at this, the pad and strip foundation was adopted. All right, so and we have cantilevers around the sides of the first floor. All right, cantilevering from grid line 1, grid line F, grid line C. So you can see that anything outside grid line F up there, right, is a cantilever. From grid line C, this part is a cantilever. From grid line 1, this part is a cantilever. From grid line 6, this part is a cantilever. So understanding that makes it very simple, and it goes up like that to the second floor, and then we have the roof and something like the parapet on the roof fascia rather on that side. Okay, so how do we move on from here? Having said that, the first thing we're going to do is to copy what we have here as the general arrangement, because like I said, we're going to be using that to make an import to Protastructure. So you want to open a very fresh and a clean environment that we can import all our general arrangement drawings. Okay, so this is mine. So the next thing you want to do is to confirm, to be sure that all your drawings fall in alignment. So I'm using that grid line F to serve as a datum, all right, to connect all my drawings, and you can see that they are all on the same grid line F. Okay, so make sure you achieve that. It will help you as you begin to go around your imports if you're working with my method. Okay, all right, so this is well done. Another thing you want to do is, if you're working with layers, that is if you want to import elements when you get to Protastructure, is to be sure that your layers have been assigned properly. But we're not going to use that method right here, because we'll be inserting all our elements accordingly by ourselves. All right, so what we want to do now is you convert this particular drawing to DXF. Okay, so you want to maybe do a save as. Okay, save as, let's name this 2025 Prota model. Okay, so and then we want to save it as 2018 DXF. Then we save. Okay, so we save that in DXF. So you can go ahead and close this drawing and ensure that you save it for reference purposes. Now that we have done that, we can go ahead to Protastructure and see what we have. Now we can create a new drawing or a new project, and like I said, let's name this 2025 Prota model. Now from here, you want to pick a template. We have different codes of practices that we use, and if you have a project that you have already used any of this code of practice that you want to still repeat, in this case, you may just go directly and apply those things into your drawing. Okay, so I would look for one that I'm sure that I applied that, so that it makes it easy for us to import. Okay, so if you have one like that, do it. If you don't have, go ahead and select BS8110, or however it is, or whichever it is that applies to your job. So from here, now we have our product structure opened, and the next thing we want to do is to import our general arrangement drawings. Okay, so if you look at your tab here, you find different options that can allow you to do everything you want to do. Okay, so but for in our own case now, we go to building setout. That's where we are starting from. So we want to import external reference drawing. Then you add the external reference drawing. Your job is to look out for where you saved the project, and this is it, the DXF. That's exactly where we saved it. Then you open it. Now when you open it, automatically imports. Then you may activate the drawing so that you can see what you have there on the background. Okay, so as you can see right here, we have all the drawings: the ground floor, first floor, second floor, and the roof. We have them import already. So maybe you don't like where it stays on your environment. Okay, so you may want to move it. So once you go back there, you can move, pick a reference, okay, and select where exactly you want it to sit. Okay, so you see that's clear enough. Now because I want to start it afresh, I would prefer to use a fresh element. All right, fresh grid lines, fresh elements. I like to do it myself. Okay, so you go back to model, select grid lines. Okay, then you begin to use the grid lines. So the first one is 1, so I'll do that 1. And one of those things is that you don't have to do it for all the stories. Okay, the next one on this floor is 3. Now I would say 2 is not on this grid line, on this floor rather, so that's why I'm not putting it there. We'll find out why as we proceed. So we have 5, we have 6 also, and we have 6A. All right, so from this place we can do the horizontal grid lines. We have A, we have A1, we have C, we have C1 also. All right, so whichever applies to your project, please do, and I'll be glad to get responses from you all on how you've been able to apply this knowledge, all right, in your next project. We have D, then I think we have D1. So this is what I use to toggle the scenarios where I do not want the grid line bubble to enter into my model inside. So I look for how it is appropriate for what I'm working on. Okay, so I have E1, which is this. Then I have E itself, so I have to change this. You see that now. Then I have F. We have F prime also. Okay, so if you check my F prime and my F, I would need to update the condition of the bubbles. All right, and I'm doing the same for this. Now I'll go back to my vertical grid lines. I have one prime, and then I have what else? Okay, so on this floor, that will be all. On this floor, that will be all. So what do I need to do next is to insert my column members, and from there we can begin to put our beams through. Okay, so we have the columns, and from making reference to where we're coming from, you discover that the columns that we have on the external from the ground floor is 300 by 225. Okay, so and that's exactly what we're going to use for this one on grid line F. You see, you have to take references from where you're starting from. Okay, and you see that some are actually stopping on this floor. Okay, and continuing on the external. So you just have to follow through what you have in your general arrangement. So you have to just use 300 by 225. 300 by 225. That's what you have there. Sorry, 225, 300. Now, but you discover that there is a way it sits into this arrangement. So you have to just find out what's the eccentricity from that point. So we have minus 38. So we go back there and we actually apply minus 38 and see if it works. So you see it sits right into it. So you do the same for the other that we have there. It's as simple as that. So for eccentricity. Now let's look out for other columns. So other ones remains 225 by 225 except for this, which is 450 by 225. So but every other one remains 225 by 225, and all this also 300 by 225. Okay, so let's go ahead and do what suits our project. So instead of this being minus, we change it to plus because of the orientation now. And let's update. So we have that. We have this also. Then we have 450. And this 74. Okay, we still have a little more. 74, then 38. Okay, great, perfect. So the others remain 225, and that's exactly what we're going to do now. 225 by 225 with no eccentricity. Please take this, this, and do not forget that we have cantilevers at some point. So, and it means they are not supposed to be on this level. That's the implication. All right, so will that be all? I think so. So let's check again to confirm if that will be all. We have 3 on this side, 3 of them. No, we'll have 2, just 2 of them on this side. Grid line 1 and grid line A forms the boundary for what we are working on. Okay, so this stays and this stays. All right, so that will be all for the columns on the ground floor. All right, so because this is the first floor arrangement, we'll just have to put the beams that we have here, then we'll go back to other things. So let's go for the beams. So the beam is 450 by 225. 450 by 225. And then you must understand the theory of primary and secondary beams if you need to do things correctly. Okay, so put that from here down to this place, and that's two, and from here down to this place, that's already cool. Then from here down to this place, I'm just trying to follow the principle of primary and secondary beam, and that's why I'm doing it this way, so that the support is actually communicated to the software accordingly or appropriately. Okay, so we have this also, we have this also. Okay, now this beam here is 450 by 150. All right, so okay, let me complete this and we'll go back to that. So all the external beams, they are 450 by 150. So let's put that there from here to this place. Yes, so it's supporting those beams. The same thing happens here. Yes, and then the same thing happens there. Yes, so those parts are cantilever parts that I spoke about earlier in the video. So we have another like that. We actually have a 450 by 225 beam on this part. Starts here and end there. But I will do it to start here and end there. All right, because obviously this can be a plain cantilever without a beam getting to this place, and which it can actually get to that place if you want it. If you want to make it get to that place, it's as simple as forming a boundary using a grid line, you know, at that point. So you may want to just create an arbitrary grid line for yourself around the place. What can we call it? Let's call it 3 prime, just for it to form the boundary with which you want your beam to stop. Okay, so with this we can have our beam and it stops here. You see that now? So that's how to go about that if you need to put in that kind of work in your project. Okay, so we have another like that. Yes, now that we have been able to do that, we want to insert slabs into our project. Slab. So once you click the slab, what thickness of the slab that you're working with is 150 mm we're working with here. Okay, and the concrete cover, let's maintain 20. The loads, we have the dead load. Well, let's use the room. Okay, impose load, right click that part, then it brings different kinds of things here. So it's a residential building you are working with. All right, so I can just put bedrooms and dormitory. That's fine for me. All right, if yours the banking halls, factories, just pick that which is appropriate for your project. But I want to stay with 1.5 general domestic use. Okay, and if the dead load doesn't, you know, you want to enter for yourself, you can come here and enter for yourself. I want to use 2.7 partition and finishes 1.5, 1.2 respectively, forming 2.7. All right, so that's exactly what I want to use there. So I can come in and insert my slabs into all these regions. All right, so I want to insert my slabs just like that into all the regions. So this is for the first floor anyway. This is for the first floor. So if that actually works for you, fine, let me know. If not, let me know the challenge or the challenges you encountered doing so. Now that we have been able to do this, the next thing is to do for the second floor. We've done for the first floor, but we need to do for the second floor. However, there is something we need to confirm here. What exactly is happening here? Do we have to pay attention to that or not? So that is a slab on the first floor and also on the second floor. This is a cantilever slab. You see that now, starting from here and there. So you have to pay attention to that too. So how do you form such cantilever? You still need a boundary lines. Let's call that, though it won't reflect in your design report. I mean, the grid line wouldn't reflect, but you need it to form that line. Let me take this off. Okay, and let us do the same thing here. Okay, so we can have our cantilever slab somewhere there. How then do you have it? How much cantilever do you have? That's 1313. Okay, so go back to slab. The type of your slab should be cantilever, which is 12. Then the thickness, you put that there. The load on the cantilever, if you have a parapet load, this is where you're supposed to put it. Okay, 1.3 meters. Okay, so if you have a parapet load, you can put it here, but we don't seem to have a parapet load on that part. Okay, so you may just put maybe a unit or whatever it is. So I'm assuming that there's a parapet load there for 1 meter height of block wall. So I'm inserting it this way. So what do we have? Oh, sorry, I've not done that. Let's go again. Let's try it again. The slab, the cantilever, which is 12, the thickness appropriately done, the load. Let's enter the value ourselves. 2.7. The rail use cantilever, the length 1.3, and let's make this let's just make it 2.87. Oh, sorry, 1313 is what I called it, and we put 1313, so and that's why it didn't work out. Okay, so it seems to be longer than what we have on the, so it's supposed to be 1.2. So let's get back there and put 1.2 here. 1200 update. All right, so it's perfect now. This is what we have on the first floor. So let's go ahead and make that for the second floor. All right, so to do that for the second floor, let's get back to see what exactly is the difference between the first floor and the second floor. Now look at this. The cantilever columns, the columns on the beams on the cantilever is reflected from the between the first floor and the second floor. So these things needs to come in right at this time. Okay, so let's see how that goes on our work. We can go back to the external reference to shift the model, that the references we're working with now. We are done with the first floor, so we can move on to the second floor. Let's see that now. So this is all we're working on now, but we need to create more floors. I mean more stories. We have the, come here, right click, you see insert stories. Now, how many story are we working with? We have the first floor, second floor, and the roof. So you have to put three. Three. Yes. Okay. So you may come back here and edit stories. Now, doing that allows you to also put names for, or I mean, description for each stories. So you can have the first floor for story one, first floor. Then you can have the second floor for story two, and then we have the third floor, or you can call it the roof. Okay, so and then the story height, you can edit that here. So if yours is 3 meters, fine. 3150, fine. Higher than that, fine. This is where you can do all of those things. Okay, so but as you can see in my own project, look at this 315033 and then 33. All right, I hope you get that now. So the implication is that on my story, if I'm editing mine, is 3333 and 3150. Okay, so we have that correctly now. I hope you understand that. So let's get to second floor. So you can see that my import is not showing on the second floor. What do I do? Click on the external reference drawing, and the story that you want it to show, come there, there's a drop down, click on story 2, and automatically it appears, and you can see that the second floor is there because I already moved it previously. All right, so let us do what we need to do, because we know that there are some columns that you know that have been there already. We may want to just put them there without wasting time. So modeling columns, 25 by 25 columns. Let's do that quickly without wasting time. All right, we have here, 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 here. So we know that these guys are not okay. All columns at this point, I believe. Now something has happened here that we need to check on the original drawing. So after now, we'll go back there to see what exactly it is. So you have to be sure that everything you're doing at this point conforms with your drawing so that there won't be any error. Okay, so what else do we have? Now there's a grid line here that is new, that seems to be new, and let's see why there is a difference on this part. Let's see what's happening. Okay, it's already showing here there is 5A, which is a new grid from what we used to have down there. So let's create a grid line 5A. 5A. So starts from here and it goes all the way down there. So we can insert our columns rightly as shown. Now there is another grid line here that is new, which is called E1. Okay, so we need to also put that. Another one that is here, okay, E. So we need to extend E, stretch down here. That's the reason why that entry did not work. So we have to put that. We need one E prime. We need E1 prime rather. So this is how to take your time out to insert all that is necessary to avoid errors. So this is E1 prime. Then you can insert the columns. Now it doesn't seem to me as though the column sits rightly. Okay, but we need to confirm what's going on there. Okay, E1. I think it's correct this way. Okay, so let's go back there to see what exactly is going on. Okay, so this is it. This and this. Now, but if you take cognizance, you would discover that these columns, there are new columns on this part. And if we put these columns right on this floor, it is as though it is sitting on the slab. I mean columns 5A. If we put it on this floor, it means it's sitting right on the slab. So we need to check our model to see how does that affect us. All right. Let's fix all, then we'll check our model and see how that affects our work at this stage. So there is a 450 by 225 450. So how much do we need to go up there? 1, 2, 3. We have 1, 2, 3. All right, perfect. Now let's check our model to see exactly what's going wrong. So right click on sorry, right click on the view. You see 3D physical model. So it loads your 3D physical model so that you see all that you've done. Now this is what I'm saying. Look at this 5A. 5A sits on the slab. The column is already on the slab. These two previous columns, they are good. It sits on the beam. But why this sits on the slab is the query. So we need to ask ourselves such question. All right. So let's get back to the general arrangement to understand what was the intention. All right. So the idea is to have our beam on grid line 5. Grid line 5A is not a proper place to have all of those things that we have fixed here, according to what we have seen in the model previous. So we just have to make that quick amendment to ensure that we are good. So let's just do that. Let's start. The columns get back here, get back here. So I'll need a big line. That's why that's it. So when we're done with this, we check how it aligns with what we previously have below. All right. Okay, so we can have the beam 450 by. All right, so we gotta have our beams on this grid now, and not on the previous grid that we already had. Okay, so let's fix our beams once and for all. We have 2 to 5, 450. All right, let's go and put that there. This ends here. So we can fix this down here instead of on the previous grid. And this can come straight on down to this. So we have this also, and we can have another beam here, have another one on this, and have another one on this. All right, we can also have another one right on this. We have one here, then we have this first. Okay, there is supposed to be a grid here, so let's have another grid line there. Okay, so let's fix our beam. We have this down here and then down here. Currently, our load still remains the same as previous. Okay, so we can fix our slabs that way. Then we'll check to confirm the columns that we had a slight issue with, to see if they all sit correctly now. All right, so now that we have this, let's check the 3D arrangement of that and see if we are good now. So we see that the columns are now sitting right on the correct, in the correct order. So none is sitting on the slabs now, so I believe we are good. Let's get to do the roof, which is the last level. Okay, there is a cantilever slab here, so let's just fix that ASAP. We have 150 thick, correct, and down this one becomes cantilever, and then the length is 1 2, and we can start putting from here to here. All right, so that's it. So this will be the last floor we'll work on, and then we'll start to analyze our structure. So to do the same thing, reflect our import on this floor, then move it to be in alignment with what we are working with. Let's use F1. F1, good. So we're just going to fix all the column points and then the beams. That'll be all. 225 by 225. If you have any questions, queries, and all, please do well to use the comment section. I will be there to answer to all that you have. Okay, we stop using this grid line, so it means this column is supposed to be here and not here. This also needs to be here and not there. Same thing happens here. All right, so now we can fix our beams and get set to have our analysis. All right, so for this floor, we'll use a different beam size. All right, so we may decide to use 300 depth or 375, as we can see here, 375. So we have 375 and 225. This can come all the way, and this one can come here. Yeah, that's good enough. Yeah, you just have to be sure that all that you're doing is way correct as touching modeling, so that you don't have to repeat all that you've done, which is unnecessary. All right, so let's keep fixing, let's keep fixing, let's keep fixing. Let's keep fixing. Let's keep fixing. Okay, so I think we're done fixing our beams. I hope there's nothing left. All right, so having done this, we can go back to check what's the condition of our project. Now you see what we have now. This is what we have. So we can also fix our walls, our beam loadings, beam wall loadings. Okay, so to do that, we need to get back to our plan. Now the first, let's start from the first floor. Right click on any of this beam, edit wall load. All right, the unit weight of wall, depending on what kind of wall you're using. Okay, the wall height, to obtain that is as simple as saying I have 3.3 as the height of that first floor, and I have 450 depth beam. Okay, so it means we are just doing 3.3 minus 450. All right, that's going to be about 2.85, if I'm correct now. And the thickness of your walls. Okay, so you can copy wall load. Let's do that by checking the 3D and see what's there. Now if you look at it, it sits just at the bottom of the beam, and that's the intention. So let's go back there and paste the copied beam wall loads. All right, so once you paste it, it copies automatically on all the beams. All right, let's do that for the second floor. So since they're the same height, or is that it? They are not the same height. The second floor is 3150. Okay, so 3150, that will be about 2.7. So you have to just re-edit the wall load for one of these and use 2.7. So let's check the 3D. So this is what we have now. You see that now? So this is how we complete our model for that. So if you want to care about your roof load, you may want to apply maybe a meter load on your roof beams. Okay, if you care really about what is there. So that will be 1 meter high. Then you can copy and then paste on all. You see that now? So check again. This is what we have. Now to run our analysis, first I like to do a building model check to see if there are errors or however it is on my project. Okay, so but first let me relabel my members. Let me relabel all, and I do this to make them, accordingly. Let's see if there are grid lines that are not in alignment. None of them. Let me see if there are, so none. Okay, so I'm good. Building model check. So you can see that there are no errors in my project. Okay, and I hope that there won't be errors in your project also. So the next thing I want to do is to analyze. Then I'll do my building analysis from here. So let me check my loading combination first. Let's do a loading generator, and you don't really have to do anything here. Then it automatically adds for you. Then analysis, building analysis. I'm analyzing all, selecting bars, and let's see. So we'll wait for a little moment till the analysis is complete. A little moment. When it's done, we can proceed to all that is next. So just be a little patient till the process is complete, so we can move ahead. All right, so the building analysis is complete. So let's check the results. Post analysis, column and wall designs. So you can check all your columns for the ones that failed and the one that passed. So all my columns passed. Oh, that's sweet. Beam reinforcement design. Let's see. Now you can filter for each stories to see, particularly for each story. So on my story one, I have about 2 concerns here. How do I solve this? So clicking that, it says design is not valid. You want to click yes, I want to do that. So this is complaining about share here, and I believe is for the cantilever reasons. Okay, and that's why it is complaining that. So we may need to redesign this section to be able to accommodate what is happening there. So what I would do basically is to increase the beam size here. So let me do the same for this. So I'll do the interactive design for this also. And let's go back to the rebar. Now let's select bars again and see what changed. So you see that it passed now. So that's the system to work around such scenarios. So let's change it to a single bar. So if you have that situation, this is exactly how to go about it. All right, so we're good. Okay, so we have to just make this 3y25, 3y20. Okay, so that works for it. And for this level, we have a situation here too. So once it's not able to correct it for us, we'll look into it and see where the problem lies. So this span also has an issue like that. It's an heavily loaded beam. All right. So what else can we do? This is a shear problem. So we have to do something about this because I guess it's the places that are heavily loaded and somewhat close to the cantilever area that's having this common issue. So let's do something about that too. Okay. There are about two things you can do. Is either you increase the reinforcement or you'd you'd increase the depth of the section. So however, increasing the reinforcement when we already have 3y25 is not reasonable. So we just have to do something that really makes sense. Okay, so I can keep my 3y20 around this place also. Yeah, let me keep it at 3y20. So let me see if a single of this works. It works. So that's how to correct this kind of issues that you have. Now this does not work, so let's update it to see. Okay, true works there. Let's see if a lesser spacing would work for one at 150, one at 150. So it definitely works. Let's take this down to 150. Let's take this down to 150 also. So that's how to correct any situation you have around like that. Good, good. So all my story one beams are good. Let's check for story two if we have situations like that too. All are good for story two. How about the roof? All good. Okay, so you can see that all that we have for our elements are perfect enough. So the last thing I'll be showing you in this tutorial is for the foundation. Okay, foundation. So let's get to the foundation. So we can go back to the plan, use story 00. Now we can insert pad footing. you can insert pad footing, and that's what I just did. Right click each, or you highlight all together. If you have previously done your foundation settings, you're good to go. But if not, click the foundation settings. When you get there, select your allowable stress of the soil, all right, and put it there, all right, and all other things that you feel that applies to your project. Okay, so having done that, you can design all. So designing all would design every column basis for you, and then tells you the result. So let's wait while this process is completed. All right, so that this process is done. We have few issues here: column 12, column 5, column base rather 19, and a few more of them. So let's select to see where the problem is. Okay, so the design has failed. Let's design this and see what makes it pass. This is 1/8 by 1/8 foundation, and it seems not to pass. That's massive. That's massive. The reinforcement is not sufficient. Punching is not sufficient. We may need to check this particular column base to see what's going on. All right, let's see for this 1.9. This is also massive. Wow, 1.9 massive. We may need to take critical look at this individual column basis. 2.1, and it still did not pass. So these are column bases that will require an extra look. All right, so which I would like to take a critical look into whatever is happening there. But however, if you are able to stick to all the steps I showed to you, you should be able to have a foundation that passed or that works. All right, so as it is now, I've been able to show you what exactly would give you a very good model. Okay, so this is how I'm able to produce something like this. So in the other situations where you have foundation issues, or in the case where you see 2 or 3 that did not pass there, you may need to take a critical look to see what exactly is happening there. Try to understand all that is given to you as a failure pattern, and be sure to attend to each and every one of them. Do not let it slide. Attend to each and every one of them. If you have questions, comments, and all of those things, please do well to drop it in the comment section, as I'll be there to answer to all of them. See you in the next video. I am Joshua.